Hello everybody! Today we prepared for you another material connected with the descriptive geometry. We, I mean Grzesiek, Mateusz and me. And today we will be speaking about the method of the revolution. And generally we have two cases if we are talking about the revolution of something in the space. And we can rotate something about the axis which is perpendicular to some plane. I mean, it will be in most cases vertical line, like B, for example. And in other case, it is special rotation about the axis, which is any line. And that first case is a simpler case, and that is why we will start from that thing. Okay, and generally, the rotation of the point or the segment, it's really simple construction. We can imagine, for example, that my fist is a point. My body is a vertical line, which will be the axis of the rotation. And if we want to rotate our point something, okay, and if we think about the possible projections, it's easy thing, because on the elevation view, the line will be only visible. Am I right? Because we see that the height of my arm, height of my fist, it's constant. If you are talking about the position of the point, of the projection on the plane view, there the circle will be visible, because the path of the motion, the trace of the motion of the point, it will be circle. We can imagine. To our better imagination, we will show you some simple animation which is made in the SolidWorks, and on the screen the three things are visible. I mean the elevation plane projection, and also we see some kind of the auxiliary view, which is the axonometric view. And we see that if the point moves in the space, on the vertical line, the height of the point is constant. And if we are talking about the plane projection, we see that the end of the segment, the point which is connected with the end of the segment, the trace of that motion is a circle. And it will be our idea, it will be our approach. Okay, let's start with something easy. On the animation, the segment was visible, the rotation of the segment, but we will start with something easier. Now I would like to show you how rotate only a point. It isn't especially complicated case. Even more, I think that it isn't especially useful case, but for our better imagination how the method of the revolution works, it is good initial point. Okay, and here we see simple point, and if I want to revolute the point, I have to introduce some axis of the rotation. In my case, like I mentioned previously, it will be the vertical line. I mean the point in the space, the vertical line is my body. It will be that such kind of the line will be visible as a vertical line on elevation view. If we are talking about the projection or about the plane view, it's easy to imagine because my body will be projected to the point. Okay, I mean the point will be somewhere here. Let's say it's a double prime, it will be A prime. Okay, and look, if you want to rotate the point A, we saw on the movie that it will make the circle in the space. Okay, it means that the circle is a flat shape, and if we have such a flat shape, we know that it will be connected with some plane, and that plane has to be perpendicular to our axis of the rotation. Okay, and if we have some plane which is perpendicular to vertical line, it has to be H-plane, because if the plane is perpendicular to vertical line, it implies that it will be parallel to another plane, I mean to the plane view, I mean to the horizontal plane. And that is why it will be H-plane. Okay, we know that the one projection of the, let's change the color. We know that if we have the line, the plane which is perpendicular to vertical axis, vertical line, it has to look like that because it's H-plane. Typically, we are denoting the H-planes by the Greek symbols, and if we're talking about the revolution, usually epsilon letter is used. Okay, it will be epsilon connected with the A, that is why I will put that it's epsilon A, and it will be perpendicular to the A. Okay, of course, epsilon double prime because it's an edge which is a plane which is perpendicular to P2 and also to A, and that is why I will denote that thing in that form. Okay, now we see the plane of the rotation. The place where the axis of the rotation pierces the plane, it's a center of our rotation. Okay, I mean, in that place there will be the center of the circle connected with the motion of our point A in the space. Okay, let's denote that O A double prime. Okay, because it will be the center of the rotation connected with the point A. Okay, and another thing, if it's a element from the A double prime, we know that the missing projection of the O has to be here, okay? Because we know that if something belongs to line, it has to lie on the projection of the line. It's obvious thing, okay? It's connected with the how the associated elements looks like, okay? It means that the center of the rotation is here. And now it's really easy to find the radius of the rotation. I mean the projection of the radius of the rotation, because radius of the projection, it's a line which connects the center of the projection and the point which is rotated. Okay, it means that our radius of the projections is exactly here. Let's denote that thing R, A. And the second projection of that thing, it will be here. RA. Okay, RA double prime, RA prime. Okay, and it means here we have two corresponding projections of the radius of the projection. And now it is really easy to rotate some element, okay? Because we know that the point A double prime, I mean the projection of the point, will draw in the space the circle, especially it will draw the circle on the plane view. I mean, if during the operation of the revolution we will see such an element. Let's assume that here we have a circle, okay? And in most practical cases, it is convenient for us, it is useful for us if we will rotate the point and transform the point to the frontal position. I mean, when the RA, it will be the segment which is parallel to elevation view, because then we can be sure that it is a true length, because we remember that if the something is in the frontal position, on the elevation view we will see true length of some element, okay? It means that if we will transform our RA, I mean the A double A prime, to that position, we will get new position of the A, I mean after the operation of the revolution. Typically it's denoted by some extra symbol in the subscript. That is why I will put, I don't know, let's say 1. And here we have the frontal position of the RA segment, okay? I will denote that thing that is RA1 prime, okay? And of course, that thing is the same as that thing. Maybe it isn't especially visible on the board, but it will be exactly the same length. Because if we are talking about segment, and even if we are talking about the frontal position of the segment, on the plane view, the true length is not visible. But now we are able, by the projection line, we are able to lift up the position of the point. Let's use, I don't know, maybe green color. We are able to transfer the new A1 prime point, and we are able to find the corresponding position of our point A1 double prime, because we know that any point from the circle has to lie on our plane of the rotation, because the subsequent point from that circle has to lie here, because we assume that the axis of the rotation is a vertical line. It means that here we have the new position and the true position of the A1 double prime point, generally of the point A. And for example, if we want to find the I don't know, true length of the segment or something like that, such a construction is really useful. Okay, guys, today we learn how to rotate a simple point, and in another material I will show how we can use that thing to make some more complicated thing. Thank you, bye.